This scenario is about how Netflix could design a database to track and manage user viewing behaviors. This system stores information about users, shows, episodes, genres, and the detailed activities of users such as timestamps and ratings. The goal is to design a normalized database that avoids redundancy and ensures efficient retrieval. We begin with normalization. In the unnormalized form, all the information might be stored in one single table, such as user ID, username, show title, genre, season number, episode name, timestamp, and rating. This structure causes problems because genre, show, and episode information repeats every time a user watches something. To fix this, we move step by step through normalization until we reach the third normal form. The final design has several advantages. Number one, it eliminates redundancy because genres and show details are not repeated unnecessarily. It supports multiple genres per show using the bridge table. It also tracks user viewing behavior in detail, recording timestamps and ratings. And importantly, it follows normalization rules up to third normal form or efficiency. The entity relationship diagram for this design includes six main entities. The user table contains user information. The title table stores show details. The genre table lists possible genres like drama, action, or comedy. The title genre table is the bridge that links shows to multiple genres. The episode table stores episode details by season. And finally, the the view activity table tracks which user watched what episode, when, and what rating they gave. Each table also follows business rules. A title can belong to multiple genres and have multiple episodes. A genre can be shared across many titles, an episode to a single title and season. And a viewing activity connects a user with an episode, recording timestamp and a rating. To conclude, this normalized design ensures that Netflix efficiently tracks user viewing behavior. The database avoids duplication, supports flexible relationships like multiple genres per show, and records detailed user activity, making it scalable, accurate, and efficient for real-world use.
First, let's look at the features of the system. Number 1. Supports business rules. A single user can watch many shows. One show can have many genres, and one genre can describe many shows. Number 2. Eliminates redundancy. Genre, show, and user details are not repeatedly unnecessarily. Number 3. Flexibility. It works for both movies and series, including episodes. Number 4. Traceability. Every viewing activity is recorded with timestamp, rating, and device details. And the problem is, Netflix records detailed viewing activities of users, what they watch, their genres, devices, ratings, and timestamps. In its unnormalized form or UNF, all this data is stored in one giant table, which leads to a lot of redundancy and inefficiency. For example, if both Marco and Liam watch Stranger Tracks and the genre is sci-fi gets repeated multiple times. And for the 2NF, we separate data into different tables. User, titles, genres, episodes, and viewing activity. This removes partial dependencies but still leaves redundancy for genres. And for 3NF, we introduce a junction table called title genre, which manage the many-to-many relationship between titles and genres. This way, sci-fi or drama is stored only once and never repeated unnecessarily. The final entity relationship diagram or ARD organizes data into these tables. User table stores user into like user ID, username, and subscription type. Title tables stores shows and movies. Genres table stores unique genres. Title genre table connects title and genres through a many-to-many type relationship. Episodes table keeps episodes linked to their shows and seasons. Viewing activity table records actual watch activity with user ID, title or episode, watch date, time, rating, device, duration, and completion status. This structure follows 3NF. It eliminates repeating data, ensures clear relationships, and supports efficient queries.
So I'm here to present to you the introduction of ERD and database structure. So the final entity, or the ERD, is organized into several connected tables. The subscription, the users, activity viewing activity, devices, episodes, titles, genres, and the types. This structure ensures that data is properly normalized and that relationships are clear. The system has several key features. It supports multiple users under one subscription plan. Number 2 is it records detailed viewing activity including date, time, duration, and rating. Number 3 is it tracks the devices used for streaming. And the fourth one, and it avoids redundancy by separating shows, episodes, and genres into different tables. So here are the relationship explanations. So subscription to user table. The business rule is a subscription can have multiple users. The effect on flow. This links each user to the subscription plan they belong to. And for example, if subscription 101 is a premium plan, then the user 01 Anna and user 02 Ben can both belong to it. The user table to viewing activity table. So the business rule is a user can watch multiple shows or episodes. The effect on the flow is this records that they watched when they watch it and how they rated it. For example, Anna watches 500 episodes on September 6th, 2025 at 9 p.m. That gives a rating of 5. Device table to viewing activity table. Business rules. Each viewing activity must be tied to a device. So the effect on the flow is this lets the system track which device is being used, enabling features like continue watching on another device.
A title can have multiple genres. For example, Stranger Tracks is both sci-fi and drama. A genre can describe many shows. The title genre table handles this many-to-many link without duplication. Each episode belongs to one season and one show. The viewing activity tables records every single viewing event, including timestamps, device, and rating. So here is the example data flow. Number 1. Marco clicks on Stranger Tracks. Number 2. The system looks in the titles table and finds it under ID T001. Number 3. The system checks the title genre table and finds T001 linked to sci-fi and drama. Number 4. It pulls genre names from the genres table. Number 5. It matches episodes and Marco's viewing history in the viewing activity table. Number 6. Finally, Netflix outputs to Marco's Stranger Tracks sci-fi drama with his watch history, ratings, device use, and episode details. And for the conclusion, through normalization, Netflix transforms messy, redundant data into a clear, efficient database that enforces business rules, avoids duplication, and supports powerful queries.